Hi Charles, I'm sorry that I'm being so late, but I'm gonna, you know, upload solutions for all the problems that I presented you as homework. So no worries. Um, yeah, I know you're busy, so I think um, you can like come back to these videos as whenever you like. So, uh, all right. So problem number 4, this is a fairly easy problem here because the answer here for problem 4 is just 1 over 32, right? Because um, it says let x be the total number of coin tosses, right? Then it says it is 5, right? What that means is you need to stop at 5 and then you shouldn't go to 6, right? And then at 5 you definitely saw the tail, right? Therefore you stop. Therefore all the other cases beforehand following up to 5 should be all you should all see has up, right? Therefore the probability of this is 1 over 32. Okay, now probability the problem 6. So I'm missing problem 5 here because there's a typo. I just found it out, and then in the next video I'm going to explain the typo, and then I'm also going to give you the solution. Okay. And before I give you the solution, you can pause the video and you can try solving that again. All right. All right. Now, so you have two regular coins here, and then one odd coin, one fake coin, two-headed coin here. So A, it says you pick a coin at random and then toss it. What is the probability that it lands heads up, right? Then there are two different possible scenarios for this, right? You need to pick a coin, right? Then you could pick from these two, right? 2/3, right? Or there is a probability that you could pick the fake-headed coin, right? And then now you want to see heads up, which means uh, what this means is that 2/3 means what 2/3 means is you pick two coins out of three, right? No, you pick these coins. You just pick one coin out of three, but there is two different possibilities for the regular coins. So if I rewrite this, then it is 2 choose 1 over 3 choose 1. So it doesn't mean that you pick two coins, right? It means that you pick one coin. And then what's the probability that it is you see has up? It's just 1 over 2. Here, a lot of people make mistake putting this 1 over 4, but that's not the case because you have only one coin, right? And then now, here, what that means is it's 1 choose 1, and then 3 choose 1. What that means is you chose the fake-headed coin. And then now you want to see the head, which is just 1, because it just says it is 1, right? Therefore, these are two different cases. Therefore, you gotta add these two. So in this case, this is 1 over 3. In this case, this is 1 over 3. Therefore, adding these, you have 2 over 3. Because these are two different cases, they're not successive. They're oh sorry, they're two separate events. Wait a minute. Okay, I put the charger in here, so yeah. So here, the answer for A is 2 over 3. And then B, it says you pick a coin at random and toss it and get heads. What is the probability that it is the two-headed coin? So here, as you see, the first part here, it is the condition here, right? And then get heads. You need to get heads. And then, what is the probability that it is a two-headed coin, right? Then the answer here is this. Answer here is 1 over 2. Why? Because first of all, you need to pick a coin at random and toss it and get heads. This is this problem is conditional probability. So let's say the event like the problem A here. Let's say the event is A, and then denote this event A. where we see has, right? Then P given A, right? Given A, but we need to see, we want it to be the fake coin. Therefore, let's say it's just F. Then it goes like this: P F intersection A, and then over PA. Therefore, down in the denominator, you need to have 2 over 3. And then fake-headed coin, and then given A, what that means is it's just 1 over 3, which is just this case, right? I want you to see the structure here of any conditional probability problems here. You have 1 over 3 here, and then 1 over 3 plus 1 over 3. So these two 1 over 3s are different. One comes from here, right? And the other comes from here. And then now, what comes up on top is this green one. So any conditional probability problem, you will see this type of structure, okay? All right, so the answer here is 1 over 2 for B. Again, I'm sorry that I'm being so late. No excuses at all. I just forgot. I just forgot. Really sorry, but I'm going to upload all the problems within today. Okay. So now problem 7, it says I pick a random number from 1 to 10. I mean, this problem is fairly easy. Okay, I want you to check it for yourself. I'm just going to write the answers down here. I mean, here PA, let's say it's A, then you are choosing from 1 to 6 out of 10. Therefore, it's 6 over 10, which is 3 over 5. And then PB means that you are choosing even number, which is just 5 over 10, right? 5 over 10. And then now P, and then it says we want to check if they're independent or not, right? And then from 1 to 6, only even numbers are 2, 4, 6. Therefore, P, A intersection B is just 3 over 10. Therefore, as you see, if you multiply these two, then you get 3 over 10 as 3 over 10. Therefore, A and B are independent. This problem is really a really easy problem here. And then problem 4 and problem 7, these are really easy problems, like textbook problems. Okay, problem 8 and problem 9. Problem 8, you just understand it here. Here, let's just check the time. Okay, suppose the probability of being killed in a single flight is this. Based on available statistics, you need a calculator to solve this problem. Assume that different flights are independent. It says it's independent. This is a very important word here. And then now it says, if a businessman takes 20 flights per year, what is the probability that he's killed in a plane crash within the next 20 years? So here, problem 8. PC, this means probability of being killed, right? Then if you say 1 minus PC, then it means that you are the probability of being alive on the airplane, right? In a single flight, right? So here, it says this businessman takes 20 flights per year. Then, what is the probability that he's alive for the next 20 years? Then, so it goes like this. What is the probability that he's alive for the next year? Then, since it takes 20 flights per year, so the probability of being alive after a year is just 1 minus PC to the power of 20. And then it goes all the way up to 20 years. Therefore, you just need to multiply from here all the way up to here. Therefore, 1 minus PC to the power of 400. Because, as you see, this is 1 minus PC, and then 20 to the power of 20. Therefore, is 1 minus PC to the power of 400. And then if you calculate this, then it's going to be like 0.9 something. Okay? So, all right, this is it for this video, and then I'm gonna come back in the next video with our last problem. Okay?